When we examine the pupils, we have an acronym that we use. What's that acronym? PERLA. The first PER stands for? Pupils equal and round. And then we've got an RL, react to light, and A, accommodate, right? All right, so pupils, first of all, we're going to look, see if they're both round. Typically, if they're not round, there's a defect in the iris. That's often congenital, okay? So usually know they have that. Then we want to know, are they equal in size? Are they symmetrical, right? Pupils equal and round. Are they equal? If they're not equal, what do we call that? Anisocoria. Anisocoria. So it's written up here. Right? That's a defect in the constriction or the dilation of a pupil, right? Anisocoria. If we see anisocoria, we then have to look, we see it at room light, we then have to look at the eyes under bright light and dim light, right? Remember that from lecture? Okay, so if this is our patient, is there anisocoria there? There is. They're unequal. So we're going to look in dim light, the dark light, and the bright light. Now, is there anisocoria in the dim light? Is there anisocoria in the bright light? Yeah, there's still anisocoria in each. Where is it worse? The dim light or the bright light? The dim, you see. There's a greater difference there, right? So it's in the dim light. In dim light, in dark light, what should your pupils do? Dilate. Did this one dilate?
Yes.
Yeah, it's big. Did this one dilate?
No.
Not so much. So which eye is the problem? The one that didn't dilate as it should. Is dilation sympathetic or parasympathetic?
Sympathetic.
Sympathetic. So we have a sympathetic issue in that right eye. Does that make sense? Patient here in anisocoria, we look at bright and dark light. Where's it the greatest? Bright light. What should your eyes do in bright light? Constrict. Did this one constrict? Did this one? No. So the problem is the left eye here. Sympathetic or parasympathetic? Parasympathetic. Constriction's parasympathetic. Does that make sense? So that's how we look at pupils being equal, right? Anisocoria, we need to look at them bright and dark light if they're not, okay? Next, the LR is what? Or RL rather? Yeah, sorry, so the second R in the L means react to light, right? So you mind sitting here? So if this is my patient, if I shine a light in her left eye, left pupil, what should happen on the left side? What should happen on the right side? Constriction. If I shine a light in her right eye, what should happen on the right side? What should happen on the left side? Constriction. If I'm shining it in the left and it constricts on the right, what's that called? What reflex?
Oh, consensual.
Consensual, indirect or consensual, right? If I shine it in the right or in the left eye and the left eye constricts, what's that called? The direct light reflex, because I'm shining directly in it. If I shine directly in it and it constricts, it's direct. If I shine in the left eye, the other eye constricts, then it's indirect or consensual. Does that make sense? What's sensory for this? What cranial nerve? What's sensory for you being able to see? Optic nerve, light, right? So it's optic nerve is sensory. And then what causes constriction of the pupil? Sympathetic or parasympathetic constriction? Parasympathetic, what cranial nerve? Oculomotor. Remember that near reaction, constriction of the pupils, convergence of the eyes, accommodation of the lens. All three of those are parasympathetic oculomotor nerve. Okay? So this is one of those, constriction of the pupil. It's parasympathetic oculomotor. So I'm going to shine in here. There's constriction of the left eye. So that's what reflex? Direct. It's present. It should be. Other side. Constriction here is consensual, right? Constriction here? Constriction here? Consensual. Should be present bilaterally. That's how you check it. Now, if I shine the light in the left eye, there is direct light reaction, but no consensual. What's our issue? Oculomotor where? On the left. So we shine in the left eye. It's sensed by the optic nerve. Optic nerve synapses bilaterally to two oculomotor for each respective side. Does that make sense? So if I shine in this left eye and there's direct but no consensual. In order to get direct, that means oculomotor's working there. It caused the constriction. It also means that the optic nerve worked because it sensed it. So where was our issue? Oculomotor on that opposite side. Does that make sense? Now, if I shine in the left eye, there's no direct, but there is consensual. What does that tell me is the problem? So I shine into the left, and you're correct, Dustin.
Okay.
I shine into the left, right? There's no direct, but there is consensual. So what do we know is working on the consensual side to cause constriction? Oculomotor. How did it figure out it needed to constrict? What worked here? Optic. What did not work on this side? Oculomotor on the direct on the side I shined into. Does that make sense? Now, I shine into the left eye. There is no direct, no consensual. I shine into the right eye. There is direct and consensual. What's my issue? Left optic. So if I shine over here and both eyes responded, I know oculomotor works on both sides, and I know the optic nerve worked on the right side, right? I come here, there's neither. I already know the oculomotors work, so the problem is the optic nerve on this side. So that's blindness in that eye. A monocular defect, if you will, if we test a static finger wiggle and it was completely blind. Does that make sense? Okay, so Perla, pupils equal and round, they react to light and they accommodate, okay? Now, an accommodation, we're gonna use that to say constriction, convergence, and accommodation. So, we did this in class, focus on the tip here, follow the pin. And what do I see occurring in her eyes? They converge and the pupils constrict, right? Now, if I want to look for accommodation, I'm going to put this about 4 inches from the face. I'm going to tell her to look at the tip. Now, look at the wall, focus on it. Now, I'm going to look here at the eye. Now, focus on the tip of the pen. Good. The wall. Tip of the pen. Good. Then I would come over to this side to check the right eye. Wall. Tip of the pen. Now, as she does this, the eyes are converging, pupils are constricting because it's a near reaction. She's looking close, right? It's all parasympathetic, all oculomotor node. But I'm trying to see if I can see that iris bulge a little bit from accommodation. So I'm looking for specifically for accommodation. But if I did it here, I could see convergence and constriction again. Does that make sense? So we see all components of the light, or of the near reaction, right? Convergence of the eyes, constriction of the pupil, and then accommodation of the lens. Does that make sense? All right, so I'm going to go through cardinal fields of gaze now, and then we'll break off and let you finish these tests, okay? So if you focus that way, or look that way for me. Now, when we test cardinal fields of gaze, what are we testing? Cardinal fields of gaze, what are we testing? Or extraocular muscles. How many of those are we testing? 6. How many is all of them? 6, right? So there's 6 extraocular muscles. What are they? Lateral rectus, medial rectus. Superior and inferior rectus, good. Superior and inferior oblique. So come close so you can watch your eyes. I would stand outside of the near reaction, about 2 feet away. I'm going to tell her to follow my pen with your eyes, not your head. I'm going to make an H in space. So I'm going to come out here, hold, up, hold, down, hold. That's half the H. I'll come back across, hold, up, hold, down, hold for a full H in space, right? So this is for cardinal fields, called testing for cardinal fields of gaze, the extraocular muscles, right? And the cranial nerves that innervate them. So follow with your eyes, not your head. Now, you see both of her eyes moving? Don't move your head, move your eyes. Okay. Did her eyes track through the entire movement? They did. So one more time. When we're here, her left eye, oh, straight ahead. What muscle, what are we testing? What muscle in the left eye? Lateral rectus. And the right eye? Medial. Okay, focus on this. Left eye? Superior rectus. Right eye? inferior oblique. Left eye? Inferior rectus. Right eye? Superior oblique. And the right eye. Down and in, right? True?
True.
Right eye? Left eye? Left eye? I'm sorry, right eye. And left? And then right eye? And then the left? Superior oblique. So we talked about how we can isolate these muscles in lecture, right? Everyone understands central gaze is different than cardinal fields of gaze. Central gaze, superior oblique, like we said, is going through several motions, right? So it's intorsion, depression, and some abduction. But when we take, if we're looking at her right eye and we come all the way medial, then we line up, we change the axis of that eye so that the oblique, superior oblique muscle is going to just pull down. That's all it's doing, and that because of the way it lines up. So I see. Look.
Like you're trying to isolate what muscles it like this?
Like look, here's central gaze. You're looking straight ahead, right? But look at the angle here of the bony orbit. You see that? Versus here. So this muscle, see the axis it's crossing. So when it pulls, there's intorsion, right? It crosses this cranial axis, so there's depression. Does that make sense? But when we start going to extreme motions, now look at the axis it lines up with. So you get a single action. Does that make sense? So when we move into these extremes, we're able to isolate a single muscle with a single action. So you come to me and someone has strabismus, what's wrong with them? There's a bunch of things going on. I'll take them through cardinal fields of gaze though, and I can tell you exactly which muscle's the issue, right? Now it could be the muscle, could be the nerve. And for something like 6, could be either, but 3, we can come back and do some other tests to see if 3 is working, the nerve itself, and then we know it's the muscle. Does that make sense? Clear as mud? All right, so go ahead, practice those real quickly on each other, and then we'll call it a day.
Is it just called